math class you take after this. Some of you is a semester. Some of you is, a few years of college worth of math classes. We'll see. So, boom. Boom. I got to make sure I'm recording here. Yep. Okay. So, the 12 basic functions is what this one is called. All right. I guess I have to leave the computer this way. All right. What we're going to learn about is what graphs can tell us the 12 basic functions and analyzing functions graphically. Why? Well, as we continue through math, we'll find that there's these 12 basic functions that come up again and again. And what happens is graphs are derived from this. They're either wider or skinnier or taller or shorter or have some more humps in them or whatever. But these are the basics that you'll see. The first one is the identity function. Y equals x. F of x equals x. Okay? So, if y equals 8x, what's the difference between y equals 8x and y equals x? The slope is 8 times higher. It'll still go through 0, 0. What about y equals x plus 2? It'll be 2 above. Okay? Y plus 2, or y equals x plus 2 will be up there somewhere. Actually parallel to that. Not that ugly of a line, but, whatever. Okay? The identity function, y equals x. The squaring function, quadratic, y equals x squared. Makes a parabola. Okay? All right. So, parabolas you'll see out in the real world in various places. Flashlights, satellite dishes, that type of thing. Okay? Those are parabolas. Cubing function, y equals x cubed, starts down. So here's another cubic function that'll have more involved than just y equals x cubed. Okay? Y equals x cubed goes through 1, 1, 0, 0, negative 1, 1, negative 2, 8, and 2, 8, and so on. Okay? All right. So what happens is this is always a positive slope if it's positive, always a negative slope if it's negative, unlike a parabola where it has a negative and a positive. The reciprocal function, okay, 1 over x. Y equals 1 over x. So we'll have a graph that's an asymptote that has a vertical asymptote of y equals 0, and x equals 0, and a horizontal asymptote of y equals 0. Okay? It is a hyperbola, but you didn't look at these hyperbolas too much. Yeah, those arrow keys just magically. No, you're not playing. All right, square root function. What's different about a square root function than all the functions we had so far? It doesn't go infinitely both directions, is what you're saying. So it's not negative, right? We don't cross the y-axis with a basic function. Now, if it was the square root of x minus 4, we could cross that y-axis, or maybe it's x plus 4. Yeah, the square root of x plus 4 we would cross over. Okay? So, they're always positive under a square root. Exponential function, like the square root function, this has a limit to it. What is limited about the square root exponential function? It is not negative in the respect to y. It's not negative with respect to y. Okay? So the x's are positive and negative, but the y's are always positive. Okay? So Euler invented the symbolization of E. That's why it's an E, which is the inverse of the natural logarithm, which E to the first equals 2.71828182459. So 1 is right there at a little higher than that. Woo! Excuse me. Right about there. 2.718281828904590. 459045. Okay, that's Euler's number. No, not exactly. You don't need to memorize it like I've memorized it. Okay, the natural logarithm function is the inverse of Euler's number. Okay, so the inverse of that is e to the x. Okay, so with inverse functions, the other one went like this. This one goes like this. Inverse functions are reflected around the line x equals y. But the natural logarithm function looks like that. So it never has a negative x. Okay? Because you can't take the negative logarithm of a negative number. Okay? The sine function, which those of you who took trig know all about the sine function. Okay? So if you don't know how to graph the sine function after trig, after chapter 2, then I guess you didn't retain much. What do you think comes after the sine function? Cosine function. Okay? They're basically the same function, just shifted over by pi over 2. Okay? They're just pi over 2 away from each other. The absolute value function always forms a V. Always forms a V, unless you're dividing by something or doing something else to it. But the basic absolute value function always forms a V. Okay? So that's one that you should know. Here's one that's a little different. It's called the greatest integer function. Okay? So it has a jump discontinuity every integer. So from 0 to 1, it's 0. From 1 to 2, it's 1, and so on. You truncate the number. Okay? Truncating is like rounding, okay? But you just lop it off. So if you have 1.12, it's 1. If you have 1.75, it's 1. If you have 1.999, it's 1. If you have 2.01, it's 2. And so on. You just truncate the number. Cut off the back end. That's where it is. Okay? So that's called the greatest integer function. Okay? It's also called a step function. And the last one is kind of the weird one that I hadn't seen much of in the past, and it's called the logistic function. So it has an asymptote at 1 and an asymptote at 0, and it just kind of halfway in between. It goes from there, and then it sweeps up to there. It's 1 over 1 plus e to the negative x. Okay? This is a function that models things in biology and business. Biology and business with that one. Okay? So it has 2 horizontal asymptotes. Not feeling this, are you? No. Okay. So out of these functions, one of the functions has a domain which is a set of all real numbers except for 0. Which one is it? Which one has a domain of every number except for 0? Did I go past it? Because we're starting at 1. Which one cannot have 0? The reciprocal function. That's what you meant. Because 1 over 0 is undefined. Okay? So you're going to have questions like that on today's homework, asking you questions about these graphs. Okay? Then it'll talk about, then you'll look at graphs and figure out, okay, where are they increasing? Where are they decreasing? Is it odd? Is it even? And so on. So, identity function. Is that increasing or decreasing? Increasing. Is it odd or even? It's an odd function because x to the first power is an odd number. If you flip it and flip it, it'll be on top of itself. Okay? So identity functions always increasing and odd. The square or a cubic or quadratic. Yeah, there we go. Quadratic. It's an even function. Always increasing, always decreasing, or does it have a decrease and increase? Decrease and increase. What is the minimum of this? 0. And the minimum occurs at 0. So 0, 0 would be the minimum. All right. Cubic function. Okay. Always increasing, always decreasing. What? Always increasing. And is it even or odd? Odd. Reciprocal function. Always increasing, always decreasing. Always decreasing. Because you figure out if things are increasing or decreasing as you go from left to right. And it's always decreasing. Even or odd? I think it's an odd function. I would say it's odd. Square roots, always increasing. I don't talk about even or odd with some of these. Okay? Sine function, even or odd? Odd. Sine is odd. Cosine is even. So you're going to have questions like that today. I think there's 11 or 12 questions. Okay? So just kind of work your way through these and figure these out as you go.